Hello students, welcome to my new video. So in this video we are going to discuss about the 10th class maths, terminating decimal and non-terminating decimal. These are the topics which is related to the unit 1, real numbers. So let's come. What is the terminal decimal? So when we are dividing any number, the remainder should be 0 without repeating the decimals. Okay, that is called as a terminating decimal. The best example of this is, if example is 3 by 2. If you are writing this one in the dividend and divisor, when we are dividing 2 1s are 2 and 1 is the remainder and point 0, 2 5s are 10 and the remainder is 0. There is no repeating decimals are there in the quotient. So where there is no repeated decimals are there and the remainder is 0, then it is called as a terminating decimal. I hope you understood. Now coming to the non-terminating decimal, when we are dividing any number, the remainder is not 0 with repeating decimal. When we are dividing any number, the remainder is not 0 with repeating decimal. Example is 1 by 3. So this number is 1 by 3, right? So we have to write in the dividend and a divisor and we have to divide it. So what will happen? Here 3 is there, here in the dividend 1 is there. So we will add 0. So 0 point is nothing but 10. So 3 3s are 9. Like that it will be the quotient will be, the decimal will be in the quotient will be repeated and the remainder will be 0, or sometimes it won't be 0, but the decimal the decimal which are coming in the quotient that will be repeatedly. So the repeatedly decimal which are coming in the quotient that are called non-terminating decimal. I hope you understood. Now let us consider the following terminating decimal number in the form of p by q. If they gave you the decimal form, you have to convert it into the p by q form. How will you convert? The step 1 is, first you write all the numbers which are given in the decimal. If it is there here 1 also, write by removing all the points, just write all the given numbers in the numerator. And in the denominator, always it will be in the 1000, 100 or tens. So write 1, and after the 1, how can we suggest it should be 3 zeros or 2 zeros or 1 0? So it is depend upon the after the point how many digits are there. There are 3 digits are there. So that's why I wrote 3 zeros. It is an easy way to understand the this type of problems. How to convert the decimal numbers in the form of p by q. Just what the numbers they are given by removing all points. For example, come here. If they gave 1.385, then how can you write that one? Just remove that point and write all the numbers which they gave in the numerator. And in the denominator always it will be in the 1. So how can you suggest these 3 zeros? Mean after the point, here it will be 5, 0, doesn't matter. After the point, how many zeros digits are there? 1, 2, 3 digits are there. So that's why I wrote 3 digits. It is in the form of p by q. And we can simplify again. 1385 by 1000 is nothing but 10 cube. I hope you understood. So similarly, come here. If they gave 0.0875 is equal to, we have to convert it into the p by q form. Just write the all numbers in the numerator. Here 0 is given, so 0 doesn't matter. So 875 I wrote by 1. So how many zeros I should keep after the digit? How many? After the point, how many digits are there? 1, 2, 3, 4 digits are there. So I will write 4 digits. So it is a 10,000. So as you can simplify here, 10 to the power of 4. It is in the form of p by q. I hope you understood these things. Now let's see the theorem 1.3. It's related to the terminating and non-terminating decimal. Just see here what they are showing in this theorem. Let x be a rational number whose decimal form terminates, then x can be expressed in the form of p by q, where p and q are the co-primes and the prime factorizations of q. Q is of the form of 2 power n and m power 5 power m. 2 power n and m 5 power m, where n m are non-negative integers. So in this theorem they are saying that now they gave decimals, we converted into the p by q form. Now what they are asking means, by using this theorem which is in the form of p by q, right? Decimal we converted into the p by q form. But here they are saying that q should be in the form of 2 power n into 5 power m, where n m are non-negative integers. Let's do some problems to understand the concept clearly. So the question is, write the following terminating decimal in the form of p by q, where q is not equal to 0 and p and q are the co-primes. And also write the denominator in 2 to the power of n and 5 to the power of m form. So just what we have to do, if they gave p by q form, just we have to simplify that and we have to convert that q. That q is nothing but denominator into the power of 2 power n into 5 power m. So first what we have to do means, it is a question is here. So if they gave 3 by 8, right? So how we have to do? First 3. We have to convert the denominator into the 2, otherwise 5. Just we have to check whether it is converting into the 2 power, otherwise 5 power. So 8 will be come into the 2 cube, sorry. So which, how 2 cube? 2 2s are 4, 4 2s are 8. So like that you should bring that into the power. And it should be in the 2, otherwise in the 5. So it is easily coming into that 2 power 3. So after that, here 2 we got it, but what they said, the denominator should be in the form of 2 power n and into 5 power m. Here 5 is not given, so we are adding in the numerator and denominator. We are multiplying with the numerator and denominator with the same power, with same power of 5. So 3 into 5 power 3 by 2 cube into 5 cube. If we cancel also, it should be this remain same. So that's why I multiplied this in the both numerator and the denominator. I hope you understood. So why we are doing this type of in the theorem, they said that it should be in the 2 power n into 5 power m. So that's why we did like that. So here 3 into 5 cube is nothing but 5 5s are 25, 25 5s are 125. We have to simplify. Here always it should be in the 10, that power should be changes. Okay, how? Because it should be in the form of 2 power n into 5 power m. So that's why 2 5 that 10, always it will be 10 or cube. That cube will be changing, the power will be changing. So overall the 125 is equal to 375 by 10 cube. It is in the form of p by q. Okay, just what we did here means we applied that theorem, we did the denominator into the form of 2 power n into 5 power m. Let's do one more problem. In this problem they gave 26 by 5. So what we are saying means, in the numerator it doesn't matter, it should be 2 power 5 power, okay, doesn't matter. But in the denominator it is very important to check whether it is forming the 5 or 2. Okay, so first we have to convert this 25 in the denominator to convert into the power, otherwise 5, otherwise 2. So let's check. The 25 will be converted into the 5 square, right? 5 5 is 25. So to simplify this 26, what we did, we shorted that 30 and 2 is 26, right? So now in the previous problem also what we did, if 5 square came, we will multiply in the numerator and the denominator with the opposite, means 2 square. In that previous question we got it 2 cube, so we multiplied 5 cube in the numerator and denominator. Now in this problem we got it the 5 square, so now we are multiplying numerator and denominator with 2 square. Already this 2 is there, 13 2s are 26, but this 2 is all about the 5 square. Okay, so when we cancel this 2, it should be remain like that, 13 2s are 26 by 25 only, 5 square. So coming here, so 2 powers are same, so 5 2s are 10 square. So here 2 2s are 4, 4 2s are 8, is nothing but 2 cube. So 13 8s are 104. 13 8s are 104 by 10 square. This is in the form of p by q by using this theorem. I hope you understood. If you have any doubt related to this concept, you may ask me in the comment box. So like my channel, subscribe to my channel, share to my channel. Thank you so much for watching.